Yeah, no problem.
Okay, welcome everybody. So today we're going to talk about Milestone 1. And as I mentioned, for those who were here a bit earlier, we're going to have a couple lectures on Milestone 1 and also this tutorial. This tutorial is very hands-on. Well, it's very practical. Goes through how we are going to code one of the Milestone 1 functions as an example. Okay, so at a glance, what are you doing in Milestone 1? You are you're building a higher level API. You're building basically a bunch of utility functions that will be helpful to you in the rest of the course. And those utility functions are also going to teach you how do you use the lower level APIs that we've given you. Okay, so we give you a library or API called the streets database. Okay, you cannot change that. And it gives you a bunch of low level information about intersections and streets and so on, about city maps. You are going to write your code in something called the street map library. Okay, so far in your programming career, you've probably only written programs that are, a single executable. And the organization for EC 297 is a little more complicated. Your source code will be compiled into a library called the street map, and we will also compile a little bit of source code, not most of it, but a little bit into the main executable. And that main executable can talk to this street map library. And when you run your user interface in Milestone 2 and so on, you'll be running, you can run this main executable. It's what an end user would use. But we also can connect to this library, and this library again is where most of your code is going, most of your functionality. We can connect to it from a tester executable, and that tester executable is ECE 297 exercise. So you've already used that for milestone 1 or milestone 0. You're going to use it again for milestone 1 and beyond. And it can also talk to your street map library. So it can basically test your functionality without an end user being involved. Okay, so most of your code is going to go in this street map library, and in your source code you'll see there's a libstreetmap directory, and that's where you should write most of your code for your project. Now the way that both the tester executable, which for this milestone is really what you care about, and eventually your main executable, which an end user would run, talk to your street map libraries. The first thing they do is they always call load map before they do anything else. Then they can make a bunch of calls to ask questions, and eventually they call close map when they're done. Okay. Okay. So you can we this tester executable is going to call load map to your street map library. It can make a bunch of queries, and in order for you to answer these queries, you are going to have to talk to this lower level API, this streets database API that we wrote to you. And it also, you can say load yourself, which takes a little while. But once it's loaded, you can ask it questions. So you can make queries to it. And once you're done, you should close it again. Okay, so the style of all the tests is load, ask a whole bunch of questions, and then close to make sure you clean up all your memory. Okay, what are you going to need to do this milestone? So you need to read the handout. And we really want you to read the handout, because if you don't read the handout, you're not going to understand the specification. It's very hard to make much progress. This is a good habit to get into as well. So don't just go on Piazza and start asking questions that are, could you tell me the first thing in the handout? Could you tell me the second thing? Read the handout first, then ask questions if things are unclear. You're going to need at least one global variable in order to pass performance tests, and we're going to show you why as we go through this walkthrough.
Is
And you're going
Streets
to
Map
use
library an executable? There is a question.
is streetsmap library an executable? No, streetsmap library is not an executable. A library is a little bit different than an executable. It is similar. It's basically a group of .o files. So it's basically a group of machine code that can be run. So that's object code or .o files. And those .o, so when you compile, say m1.cpp, it makes m1.o, an object file that a computer can almost run. In order for it to be able to run it, you need to do one final step called linking. which connects all the functions together, and then you have an executable. You can also, instead of making an executable, you can make a library. And a library is basically a grouping of .o files. You cannot type its name at the command line and have it run. It doesn't have a start point, so it will not run. But it basically is a whole bunch of functions all linked together and ready to go that can be called by an executable program. Okay, so it basically provides the intelligence of an executable program, but you can't type its name at the command line. Does that make sense? That's why instead you type ECE297 exercise. That's the name of this tester executable. And that tester executable is making all sorts of these calls into your library to check that it works. All right, so hopefully that answers that question. Okay, you're also going to need to use containers from the standard template library. So vector, list, map, unordered map, multi-map. You won't necessarily need all of those, but we've gone over them all and went over them all because they're all reasonable choices. I mean, it is likely that you're going to wind up using at least most of those in your project. And you're going to have to choose which ones, as well as coding their use. The nice thing about STL is, as you've seen, it doesn't take very much code to get different data structures. So really, you choose the code, choose the data structure, and then STL helps you implement it very quickly. Okay, so what are you given? So you're given a small skeleton file. It's a little bit bigger than this. It's got a little more commenting, but it's m1.cpp. Okay, so that's the skeleton file that you will have in your Git repository in your working directory when you go through the Milestone 1 handout. It tells you how to get set up, just one command, and then you'll have some skeleton code. And this is in that skeleton code. And it basically says, you're going to have to write a function called load map, which is past the name of some map. And right now, the skeleton code is not really doing anything. You're going to have to fill this in. You're going to have to decide what data structure should you set up. And when you're done, when the tests are done or your main program is done, close map will be called, and it cleans up all your data structures. So it should free any memory that you've allocated and unload any databases that you called our APIs to load. Okay, so this is all going to be a little vague at first. This is your skeleton code, but you probably don't really understand what exactly am I supposed to do. That's what we're going to do this walkthrough to kind of show you by example, concretely. Okay, so how should you attack M1? So you follow the handout instructions, and it tells you, okay, run this EC297 init command. Now you're set up with the skeleton code. Compile the code and run the tester, EC297 exercise, and it takes a milestone number. So you're going to run it for milestone 1. You're going to see what happens. Okay, and this is what's going to happen. You're going to get a bunch of errors that are undefined reference errors. Anybody know? So this says, let's read this first one. It basically says in a certain file, and this is a file where we've written some of our tests. This is actually an ECE297 exercise. So it's the tester executable that's calling your libstreetmap library. And it's saying on line 185 of that file, there's an undefined reference to this function, find street segment length, which takes an integer. And then it says, there's another undefined reference on line 190 and so on. And there's lots more, okay? And eventually it says, we failed to build the unit tests. So we couldn't actually make the tester executable, could not actually properly compile and link to your library. So what happened? Anybody just type in the chat or unmute yourself. What do you think these undefined reference errors mean? How are we going to get rid of these? Maybe we forgot to include that HPP file you didn't link. So it's a reasonable guess, but it's not a problem in the unit tests themselves. So we didn't forget to include an H file. It didn't link, you're right. So it did fail to link because it could not find an implementation for this function. So yeah, the function doesn't exist. A header file just says, here's how you'd call this function. And the m1.h header file, let's see, I haven't shown this to you yet, but there's an m1.h header file, and it actually defines all of these functions you have to write. So it does say, give the interface, or declares all of these functions you have to write. So the m1.h has declared this function, so it's not a lack of including the right header file. This error means you told me this function exists, but when I actually compiled and then I tried to link all the object code together, I found that there is no implementation for it. You declared the function in the header file, but you never wrote a body for it in any CPP file. So it doesn't exist. So we need to write it. This is m1.h. And so, as I said, this declares all the functions you have to write. This is a specification of what you have to write for this milestone. So read the handout. It gives you important background information. And then this header gives you kind of the details. So it says, for example, you need to write a function called find street segment length. It's going to take one parameter, which is a street segment index. Now, street segment index is actually, I don't know if you guys have seen type defs or not, but it's basically an integer. We've created a nickname for integer, and this is just to help you remember while you're passing an integer in here, that integer is supposed to represent the index of something called a street segment. All right. And you're going to see in lecture a little more in a few slides what that is. But this tells us, okay, we have to write that function. We know what its inputs are. And the comment above it tells us what it should do. It should return the length of that street segment in meters, and it has to be moderately fast. Okay, because some of these functions are also going to be speed tested. All right, so that's the specification of what we need to do. We haven't written any of these functions. So that's why we're getting these undefined reference errors. When the tester tries to link everything together, it finds some of these functions don't exist and it complains. So we need to write them. And in this tutorial, we're going to focus on this function. Okay, it is find street segments of intersection. And it takes one input, an intersection ID. Again, this is actually an integer, but we're giving it a fancier name of intersection index. So in your code, you can tell this is an integer that should be the ID, the index of some intersection. And it's going to return a vector. Okay, so an STL vector. And that STL vector is actually also going to be a bunch of integers, but we're going to give them, again, a fancier name. We're going to say these integers are street segment indices. So they should refer to little bits of streets. And that just helps you keep track of, okay, while they're integers, they're supposed to be this kind of index. All right, so we're going to see how do we write this function, and you have to do it for every function in m1.h. Okay, so we compiled, we ran EC297 exercise, and it just refused to run. It basically said, I can't find your functions, I won't build, I won't run. So in order to make any progress, what you should do is create empty, or sometimes these are called stub implementations, of the functions in m1.h. So it just basically means you're going to write this. It's not going to pass the test. It's not going to do what it's supposed to, but it is going to compile. So it's going to return the right thing. And that's enough for EC297 exercise to now successfully compile, successfully link, and you can actually run the tests. And they're going to fail, but at least now you can run them. So you'll get rid of the build errors. Okay, so a stub implementation, is very simple, right? If I go back here and I was to look at what is the stub implementation, I just basically copy over this function prototype. I put in open brackets. I can basically say return. I can declare a vector. I don't think I want to write this whole thing, but basically I can allocate a vector or declare a vector of the right type and just have it be empty, have it be default constructed, and then I can return that vector. Okay, so what I just wrote is not quite syntactically correct, but that's what I mean by stubbing something out. You write the simplest thing you can that actually just returns a value of the right type, and it'll compile. Okay, so we do that for all of those functions in m1.h. So we don't write that. We don't write those stub implementations in m1.h. We write them in m1.cpp. But they're really simple. Once we've done that, it will compile, it will link, we run the tests, and we're going to fail almost all of them, right? So we fail them because our functions don't actually do anything useful. they return empty vectors or they return 0, whatever type we have to return, we return something really simple. So it's obviously not correct, and we fail all the tests. But this is still progress. We can compile, we can build, so we can see where we stand. And I'll pause for questions in a minute, but I probably have to tell you a bit before you have any hope of understanding what's going on. So we're going to talk about this more in lecture, but in brief, just so you understand the function we're trying to write, we're representing city maps in pieces. So here's a piece of Toronto, and we represent it as kind of two key things. Intersections, so that's where streets meet, and street segments. And a street segment, this is a street segment here, a street segment is basically a city block's worth of street. It goes between two intersections. So College Street is long. College Street would include many street segments. So every single thing that I'm circling would be a street segment, that happens to be part of College Street, but each of them is a different one. And this would be another street segment and so on, because there'll be another intersection down here. Okay? So those are the two most important concepts of how we're dividing up and representing a map. Okay? So what are we trying to do? We're basically trying to write one of those functions, and the header file told us what it needs to do. It's called find intersection street segments. So this is the function name. That's what we have to implement according to the header file. The header file is the specification. It takes one input, an intersection ID. So that's going to be an integer, okay, between 0 and the number of intersections. -1. Okay, so this is an ID for our intersection. And given that ID, so that's going to refer to one of these intersections. So maybe it refers to this one. If we passed in ID 53, it might refer to that intersection. But it's some specific intersection for any integer that we pass in. And we have to return a vector of street segment indices. So each of these street segment indices also has an ID. So this street segment index might have an ID of 1500. Okay, so that would be one of the values that we'd have to return in that vector, but it wouldn't be the only one. We'd have other street segments here, so we might have 4 different numbers to return in that vector. Okay, and that's what we need to fill in and return. So to start with, we know we have to make a vector of these street segment IDs, which are really integers. So this is really a vector of integers. If we replaced this by int, it would actually be fine. It would generate the same code. It would just be probably a little harder to read. So we're going to keep using our type defs, our nicknames for integers. So we created an empty vector, right? This is the default constructor vector, so it creates a vector with nothing in it, and we're going to return that vector. And in this function, we have to fill in what should go in that vector. Now, our only input is an intersection index number, so we're going to need more information to fill this in. We need something outside the scope of the function. And what we're going to use is we've given you an API that we've written called Streets Database API that you can ask questions of. And it processes the raw map data that we got from an open source database. Okay, so in that Street Database API, in its header file, which defines how can I call this thing, there is a structure called Street Segment Info. And it has a bunch of different data members in it. And one of the things it has in it are the intersection indices that this street segment connects to. So a street segment goes between two intersections. So it goes between from, which might be a certain ID of intersections, might be 1800, and its other end is called to, and that'll be a different intersection ID, might be 2750. Okay, so it's got two different integers that are recording what are the two different intersections that I connect to. And it has a bunch of other information in here that am I a one-way street? So if I'm a one-way street segment, then I can only go from the from intersection to the to intersection, but not the other way. It's got a speed limit, etc. So it's got a bunch of other information in here, but we don't need most of that right now. Okay, so we can get various information by making calls to this street database API. So there's one function in street database API.h called get num intersection street segment. So these names are kind of long, but I'll show you in another slide how to kind of interpret the names. And part of the purpose of this milestone is to get you used to talking to this streets database API that we wrote. Okay, so this is a function we've written. It already exists. You just include this header file and you can call it. So when you call this function, you pass it an intersection index. So an integer again that refers to some intersection. And what it's going to return is how many street segments connect to it. So if I've got an intersection that four pieces of street come into, this is going to return 4. And then I can also ask, what is the ID of each one of these street segments? Okay, so maybe this was, I'm going to show this on the next slide, but basically I can ask for this intersection. So I pass in the ID of this intersection. Maybe that was, 1700. And I pass in a small integer going from, in this case, I've got 4 street segments that connect to this. And I know that because I already made this call. So I could basically ask, give me the first one, so I'll pass segment number 0. Give me the second one, so I'll pass segment number 1. Give me the third one, so I'll pass segment number 2. Give me the fourth one, so I'll pass segment number 3. So this segment number just allows us to ask questions about all the street segments that connect to this. And we're always getting an ID back. So we're getting back the ID, which is going to tend to be a bigger number. So this might be ID, 51,000. Once we have the ID of some street segment, we can also go and ask for more information about it. We can say, give me the street segment info structure for that ID. I found that I have street segment number 51,000 connecting to this intersection. Go get this data structure. That's the data structure I just showed you. Has a bunch of subfields. And now I can look at all sorts of information on that. Okay, so there's lots of different parameters here. Don't worry if this seems a bit much. You're going to get used to it as you code with it. Okay, so this may help you understand some of the functions in Streets Database API. The naming function is starts with some word like get. So if it says get, it means it's a lookup. So you want to find some information, and typically these are fast. So it's like an order 1 lookup. Then the next word is like the entity. So I am asking a question about an intersection. So therefore, I am going to pass you the ID of an intersection. My question's about an intersection. And then an attribute. So the question I'm asking you is, I want to know something about the street segment. So I want to get some information. I want information about an intersection, so I'll pass you an ID for that. And what I want to know is the number of street segments. So tell me how many little pieces of street connect to this intersection. So for the little thing I drew here, that again would be 4. Okay. Yeah, I see a question. The numbers 0 to 3 in your example are the segment indices? Yes. So there's basically indices to say, I know there are 4 segments. Tell me about the first one, the second one, the third one, the fourth one. So they allow you to ask about each one of them in turn. So that's a good question about what are those numbers 0 to 3. Okay. So that's how you can interpret the names of these various functions, but they're all commented, and there aren't an enormous number of them. So the Streets Database API is a header file that's well commented, so you can understand, what questions can I ask. And again, that's kind of the purpose of Milestone. A key purpose of Milestone 1 is to get you familiar with this API. So to complete Milestone 1, you have to read that header file carefully and learn how to ask questions from it. Okay, so what is this data? This basically is just a nicer drawing of what I showed you before. If we passed in intersection ID 232 to that function, we can get back information like the street segments that connect to it are these three IDs. And to do that, you would use the sequence of calls of, well, you would say how many street segments connect to this, and the answer would be 3. And then you could ask, tell me about the 0th one, tell me about the first one, tell me about the second one, and you would get back these IDs telling you what are the IDs. Sorry about that. What are the IDs of the things that are connected to it? Okay. Oh yeah, and I should have clicked through the animation. So get intersection street segment of intersection 232 and 0th or first street segment would return 311 in this case. When I ask the same question, but the first, the 1 or second street segment, I would get 321. And when I ask the same question with this index of 2, I'd get the last one. Okay, and I should never ask this question. This particular intersection only has 3 street segments connected to it, so I shouldn't ask this question with a 3. Okay, the API will crash if you do that. But you know that this only has 3 street segments connecting to it because you asked how many are there before. We have that other API call. Okay. Let's see. I see some questions here like what determines orientation. There's more information in here. So from indices and these API calls that I'm showing you are all just about connectivity. The indices are just IDs. They're numbers that you can use to refer to intersections and street segments and so on. When you get an intersection, it will connect to some number of street segments. You can ask how many, you can ask what their IDs are. You can't make any judgments about the first one is going to be north and the second one south or anything like that. You just know I have 3 street segments connected to me, and these are those 3. Oh yeah, and actually I should have looked at my slide more carefully. The first thing we called is get intersection street segments. It said 3, which told me I can make calls to get those street segments, and I should use indices from 0 to 2, so I can get all 3 of those. Okay, I should never ask with index. I should not ask this question for intersection 232 with an index of 3 or segment ID or segment index of 3 because it doesn't exist, right? So that's what's going to crash. But I know that because I was told there are only 3 street segments here. Okay. Let's see. And then you can call that get street segment info function. So if I wanted to know more about this first street segment ID that I got back, I can call get street segment info with it, that ID 311, and you'll get that structure, street segment info, and it'll tell you more information about this particular street segment, like its speed limit, its various latitude and longitude points along it, and so on. Okay. Okay, what other functions do we have in this streets database API? Let's see. Well, I guess these are the functions I just talked about, so I shouldn't say that. And I guess I've already mentioned this. Intersection index, street index, etc. These are all really just type defs, which means like an alias. They're nicknames for integers. So if you mix up your IDs, you get an intersection ID and you pass it into, you get a street segment ID and you pass it in as if it was an intersection ID, you won't get a compiler error because they're all actually integers, but your code doesn't really make sense. So when you're naming variables, give them good names where you can keep track of, is this an intersection? Is this a street segment? Because otherwise it's easy to confuse yourself. And the compiler can't catch those errors because of the fact that they're all really aliases for int. So it's going to accept swapping them around. Yeah, okay, so there's a question. I'm confused on the purpose of type defing the variables to ints. Isn't it a little confusing? It's debatable. So usually this is considered better. You could say, look, I want to know these are ints. So there's a style where you just go, look, just make them all ints so I can tell they're all int. This does make your code, if you declare some variable that you want to store an intersection to be of type intersection IDX, then it's more obvious to the person reading it, okay, this is actually an intersection ID. And it's also similarly helps make the API more clear of we expect an intersection ID. So once you get used to the API, I think this actually enhances clarity. But if you're trying to see, well, I just want to know what do I pass in, you're right. An int might be easier to understand, but it doesn't give you quite as much information. If you use good variable names, it still could be okay, but you really need to know this is an integer, but don't pass an arbitrary value in here. Make sure that the value you pass in makes sense as an integer ID, an intersection ID, and not all integers would satisfy that. But you're right. It is kind of a style thing. If you just go, I
Sorry,
want to know integers, and I'm going to
so-
rely on the name you give the variable to tell me whether it's an intersection or not. That's not a bad style either. We've chosen to use
sorry
type.
for the interruption, Vaughn. There is still one more advantage to type def as well. Let's say you are writing a big code base, and then at the end you figure out you want to use unsigned, for example, instead of in. So in that case, you only have to replace one line instead of going over all the code and replace all the types.
Yeah, so that's a good point too. So if you think you might one day switch it away from int, and unsigned int might be a choice. Maybe you need even bigger integers. So there are 64-bit ints. So if you think that you might do that one day, then these type defs mean you need one line of code change rather than some huge code change. Are you treating these structs like objects? So in C++, a struct and an object, you're talking about this one. Let me go back to it. You're talking about this struct, because the only struct I've shown you is this one. In C++, a struct is almost the same thing as an object. In fact, the only difference is that by default, in a struct, all members are public. So by convention in C++, people tend to use the word struct when they're making everything public. Because you'll notice here, you can just directly access all the data, which is the same as what you would have in a C struct. And in C++, it's the same as a class with all the data being public. You could use a class here. I could change this and it would be identical if I put class and then I put public so that everything is public. That is identical. From the compiler point of view, it does not matter. It's kind of a convention that many people use in C++ of if their class is really simple, they're just going to store data and they're going to make all the data public, they'll just call it struct because then everybody knows what they mean. They don't even have to go look at the class to see if it's all public. Does that make sense? Now, structs can have functions in C++. So I see a question. I thought structs couldn't have functions. In C, they couldn't. In C++, structs can have functions. So they really are just classes. But they default to everything being public. And the convention is people will commonly use them if they actually just say, I'm going to make a bunch of public data and wrap it together. I'll call that a struct. Okay? So don't be confused by using that struct terminology. Okay, so that was about the names that we're using, or the types we're using. They're really all integers, but we give them these other names to try to help clarify the API. Okay, so we're going to put you in breakout rooms, and I think, Abid, you may have to do this. Let me see if I can actually do this or not.
I already have them ready, so I'll just open them right now.
So you're going to go into breakout rooms. We can't actually have you code this in an online IDE because you're using libraries that we wrote and so on, like Streets Database API .h. That header file wouldn't exist in the online IDE. So what we're going to have you do is just go in a breakout room and just discuss how would you implement this function. So we've talked about this function that is supposed to return a vector of street segment IDs. What are you going to need? We've talked about tell me how many street segments connect to an intersection. And we can get, for a certain intersection, we can ask about the street segments that connect to it using this function. and you can go back a couple slides if you want to see what exactly was that function again. And you can also ask for the street segment info given any street segment ID. Given some or all of those functions, you should be able to write what we need. And it's not a lot of code, right? So this box gives you some idea. It's not that many lines of code. You have to load up a vector. So we've already declared the vector, and you're going to return it. And actually here you can see we declared the vector as int, right? It compiles because we could have actually called this street segment index. It means the same thing.
The
Right?
slides
So we
are
could have done
posted
either.
on
In this case, we did
Quarkus.
int. Probably change the slides afterwards to change it to street segment IDX to be more consistent. Okay, so we're going to put you in.
So I typed in the functions that you might need so that you can see them in the breakout rooms. And the slides are posted on Quarkus by now. So if you want them, you can go get them.
Okay, so I was going to put you in the breakout rooms. Not that long, maybe take just a few minutes and discuss how you write this and put it in Notepad or anything you want. Don't worry about whether it's syntactically perfectly correct. And when you come back, we'll just have people type it in the chat or paste it into the chat, and we'll see how it looks. Okay, so why don't we launch the breakout rooms?
Yeah. They are not published. Sorry, I have to publish them. Yeah, okay. Now they are published. I'm sorry about that.
Okay, welcome back, everybody. Okay, so does anybody have a solution that they want to paste into the chat? I'll post a PDF version right after this meeting. So. And the slides have just been made published. So they weren't published before. So now they are. Does anybody have a solution they want to paste into the chat? And don't worry about whether it's perfect. Just want to look at it and see the broad outlines of it. Since you're not running this through a compiler, you're never going to get it. Well, you're rarely going to get it perfect without a compiler. So if you're thinking I could paste it in, but I've been too nervous, go for it. I'll give you another few seconds to try it.
Could I just say it instead of typing it out?
Sure. Just tell us how you would attack it.
Wouldn't it just be one line? Wouldn't it just be get street segment and then assign the return value from that function? Not the return value, but the return values to the vector?
Close. So you're right. It's not very many lines. So that's the right idea, but you do need more than one line. So let me show you what. Yeah, you need to iterate. I can see a couple of comments. So you need to iterate, basically get the count. Right. So this function is going to give us the count. And then from that count of how many street segments there are, we can actually ask one by one, okay, tell me the idea of the 0th one, the first one, the second one, and we can put them all in a vector with pushback, and that should work. And I see Kisao looks like he's basically got it. Yeah, so that code that Kisao has just typed in looks completely correct to me. So. Or certainly has the right idea. It may not be perfectly syntactically correct without a compiler, but that looks right. So this is the function that we wrote, and it follows exactly what several people just said. Get the number of street segments that connect to this intersection, and we're going to iterate through them. So we can iterate through them asking, okay, for the 0th one at this intersection, for the 0th street segment, tell me what it is. What is its ID? I want to store that ID in my vector, so I'm going to use pushback to stick it in my vector. I go through this loop, a few times, and when I'm done, I've got all of the IDs that I need, street segment IDs in my vector, and I return it. Okay, so if we go, we're running low on time, so we're not going to go out and demo this, but if we type that code, we build, and then we run EC297 exercise, we'll be told, how do we do on the public tests. And we could run everything. There are a whole bunch of tests in this, but I know I only wrote a test for intersections. I can actually tell this exerciser to just run those tests. So this says only run some tests. The tests I want are those that include the word intersection. That's what this means. And what happens? It will fail one test. It actually passes the functionality tests. That's what this means. So it passes the functionality tests related to intersections, but it fails the performance tests. And so it's not fast enough. Okay, so why did we fail the performance test? Well, m1.h gives us a little more information. This is the function that we're trying to implement. Okay, so that's this prototype. And it tells us what we need to do, find the street segments that connect to the intersection. And it tells us something else. It tells us that the speed has to be high. Okay, so what does high mean? Right, that line. Well, different functions have different speed requirements, and high is the toughest. Okay, so the definition of high is function has to be very fast, and it's likely going to require the creation of data structures that allow you to rapidly return the right answer rather than always going to the Streets database API. Okay, so what does this mean? It means, instead of just asking Streets database API a bunch of questions, your load map can do anything. So you can have your load map load some data structures of your own that allow you to answer questions faster. And when you see the high speed requirement, it's likely you're going to have to do that. Like if you find some other way to do it and you pass the speed test, that's fine. We're just telling you that we think you're probably going to have to actually store some data in order to pass this speed requirement. Okay, and there are other levels too. Moderate means you should make it reasonably fast, but we don't think you should need to store some extra data. It's okay if you do, but we don't think it's necessary. And none means we don't even test it at all for speed. Okay, but this one is the highest level. Got to be really fast. Okay, so what can we do? I mean, this code doesn't look bad. So, and the functions that we give you in Streets database API are not coded to be really slow. They're coded to be reasonable. So you can assume that each of these functions that you're calling, and you're calling two of them, are order one. They just look up the information quickly. So if they're order one, what is the complexity of this overall function, which does include a loop in it? So what do you think the complexity of this function is? Yeah, order n. And so that's right, because we have to loop through n things. Now we're going to use the word k. I'm going to use the variable k. The reason I'm going to use the variable k is n sounds like it could get big. All right. So I'm just going to change the variable name to k. Why? Well, how big could k be? Okay, so in a city map like Toronto, you can have hundreds of thousands of intersections. So Toronto has about 150,000 intersections and about 200,000 street segments. So it's a lot. Okay, so n, number of intersections or number of street segments, can be big. How big do you think this k can be? Yeah, so I see Kizel saying maybe 6. Yes, this k is not going to be very big. The reason it's not going to be very big is you cannot make a city where an intersection has 150,000 streets coming into it. You commonly will have 4. Maybe you got a few weird intersections where you got 6. Maybe you got a really wicked one with 8. Once you're getting up to like 64 streets in an intersection or something, like you have a really dangerous city. Okay, so this is typically going to be more like 4, maybe 6 for a complicated one. So it's not too bad. Like this loop doesn't execute that many times, but it's still not quite fast enough. So even though it's a pretty reasonable implementation, we need to go faster. So, and I see someone saying the Arc de Triomphe has 12. And I was in Paris a year and a half ago, and I was careful walking, and I didn't drive. So I'm not doing any 12-way intersections. Okay, how could we speed this up more? Because this code looks pretty good. And remember this huge hint. This huge hint is that before we call any of your functions, like the tester is going to call this, it's going to call load map first. So you can do anything you want in load map. What do you think we should do? Any ideas? So just give me a broad suggestion and we can keep going. Use map instead of vector. I have to return a vector here, okay? Because the specification, the function I'm implementing must return a vector, okay? So that's what I'm told. The other thing is what I'm doing with vector is actually very fast. So this pushback is faster on average than an insert in a map, okay? Insert in a map is order login, pushback is on average order 1. So nothing I'm doing with the vector is slow. What's actually getting me is this loop. And in this loop, I make a couple of calls to this API that I didn't write. Well, I did write it, but you guys didn't write it as students. So you don't quite know how fast it is. It's not bad, but maybe not the fastest. And we got a loop going through it. But yeah, I can't change what I return. I must return a vector. Why not call? Yeah, so not call this. So can I get rid of this loop? Can I get rid of this call? And yeah, that's the idea. If I can get rid of this loop, I could be faster still. But to get rid of this loop, I need to do, this is what that Streets Database API gives me. So to use the Streets Database API, I fundamentally need this loop, but the loop is not fast enough. So this is the hint, right? In that we're going to call load map before we call any of your functions, before we speed test them. So we can load anything we want. All right. So we can, in load map, load a data structure that's going to make this function call faster. So what can we use for intersection street segments? And we're basically out of time. So let's take a quick poll. We can either keep going and we'll record it for those who have to leave, or we can pick up next week. What would you guys prefer? Okay, so see, next week, keep going. Next week, keep going. Okay, so it's a mix. Let's see, but it seems to be more. Okay, so a lot of people have class right now. Okay, so I think what we'll do then is, Abid, what do you think? I think we can make up the time next week. So
Sounds good. Yeah.
okay, so I think we're gonna end there. But yeah, to speed this up, you have to actually allocate data. We're gonna have to pre-compute some things in load map, store them so that we can keep going. And we'll pause there for this week. And you can, if you want to read ahead, you can take a look at the slides. So the slides we'll post the full slide deck, but finish going through it next week.
This shouldn't discourage you from starting Milestone 1 earlier. So start reading the handout. It's very useful to finish reading it. It's a long document, but it has everything you need to know in there.
Yeah, and the document has the header files pasted in. So it's not as long as it looks because a lot of it are these two header files, the header file of what you need to do and the header file of what you need to talk to. This week you're finishing off Milestone 0, but I know many of you have actually already completed that. So Abid's exactly right. If you get going on Milestone 1, start reading, you can start coding, then you'll be ahead of the game. Okay, thanks everybody. We'll hang out in case there are any questions for the next few minutes.